Okay, so in section 1.3, we started out looking at linear equations. We looked at two pieces of information. We looked at a standard form of an equation, and then we also looked at very specific types of graphs, which would be vertical lines and horizontal lines. So we're going to expand what we're working with in section 1.4 to include other pieces of information about linear equations. The first piece of information is going to say that we no longer have these very specified zero or undefined slopes. Our slopes have other possibilities. So if we're looking for the slope of a graph that's not zero or undefined, and it happens to be through the points x1, y1, and x2, y2, there are several versions of slope. So one of them would be that we have y2 minus y1 over x2 minus x1. That's one of them. You could switch it around and you could do y1 minus y2 over x1 minus x2. That's fine. Doesn't matter the order as long as the subscripts are matching, right, vertically. Sometimes you see it written, I'll write you a couple more, as change in y, it looks like a delta, over change in x. They look like little triangles. Or somebody might sort of give a verbal description of it as rise over run. Have you seen any other versions that I haven't mentioned for slope? Those are the ones that I see used. And we're going to take, in fact, 2 points, and we're going to find a slope. So our 2 points are 2, -1, and 5, -3. And it doesn't matter where you start. It does matter that the y is on top and the x is on bottom. Okay, that's the part that's going to be important. So if we want to move just from left to right, this is the first y value listed, and a y value would go on top. And then the other y value would go next, and it would be subtraction of that next y value, so minus a -3. And if I started with the first point for the y's, I have to start with the first point for the x's as well. So that's a 2, and then minus, in this case, a 5. So minus a -3 on top is actually positive, right? So 1 minus a -3, or 1 plus 3 is 2. And 2 minus my 5 on bottom? -3. And that's my slope. Any questions on that one? Okay, try the next one, the next two actually. Go ahead and find the slope on each of those, and then I'll make sure that everybody's sort of on the same track and has the same pieces of information after you've done that. What'd you guys get for the slope on number 3? 0. Should have gotten 0. No matter which order you do it in, I would do mine as, whoops, I'm on 3. Let me move up to 2. As 3 minus 3 on top, and then 7 minus the -10 on bottom. So mine ends up looking like 0 over 17. Yours might look like 0 over -17 if you switched the patterning of around. But 0 over anything that's not 0 is 0. Now, we just did 0 slopes back in section 1.3. Just for reference, what kind of a line does that make this? If it's a 0 slope. It's a horizontal line. So just to remind yourself, this is a horizontal line. It doesn't ask me that, but it is. What happened on number 3? What was its slope? It was undefined, that's right. So again, you should have gotten something like 9 minus a -3, or the other way around. And on bottom, you ended up with 0. So mine ends up being 12 over 0. Division by 0 is undefined. It's an undefined operation. So if I did have this line, and I was told then to graph it, what kind of a line does this become? Yeah, it's a vertical line. Okay, now we already mentioned one of the forms of a line, the standard form. So when we had the standard form, this is back in the last section, it was ax plus by equals c, and there were some conditions on a, b, and c. I'm not going to write them again, but we've already seen that one. There's a couple more forms of lines that are very helpful depending on what information we're given about the particular line we're working with. The first one's called a point-slope form of a line. So this particular form of the line looks like y minus y1 equals m times x minus x1. Your slope is m, and you're going through the point x1, y1. The third one on this one is probably the one that's most common to you. If I asked you, what's an equation for the line, and you remembered anything at all about lines, but not very much, this is probably the one thing that you would remember, aside the fact that they're straight or something like that, right? Is y equal mx plus b. Agreed? Of all three of those lines, that's the most common one. And I think part of that is because it's in such a nice form that makes graphing easy. Calculators use that as inputs. There's a lot of reasons for it being the most common one to us. But it's not the only option. So we're going to do some examples with lines in them, or some examples that are going to create lines. It gives us 2 points, and it wants us to find the equation of the line through the points. So no matter which of these equations you use, and to be perfectly honest, the first one, standard form, rarely useful. We're going to be sort of, settling in on number 2 and number 3, either point-slope form or slope-intercept form. And if you take a look at both number 2 and number 3, slope is a part of what's going on. We've got to know the slope. Without knowing the slope, we're stuck. So the first thing we're going to use, whichever equation we'd like to find this with, we're going to find the slope. So we had already found slope on 3 problems today. So find for us the slope of this particular set of, or pair of points. We did that one before, didn't we? 2 over negative 3. Okay, any questions on the finding the slope part? All right, now you guys get a pick. Would you like to use number 2, the slope, point-slope form of a line, or would you like to use number 3, slope-intercept form? Either one are usable. Which one would you like to use? 3? Slope-intercept form. Okay. If you decide to use 3, some of you are like, wait a minute, I wanted to use 2. It's okay. Let me use 3 so you can see how it works. Maybe you'll like it. All right, so y equal mx plus b. We know m because we just found it. Agreed? We don't actually know b, the y-intercept. But it's okay because we can use this equation to find it. Because we know an x and a y. In fact, we know 2 x's and y's. You just need to pick one. So I'm going to pick the first one just because it's first. So in the first point that we were given, what's the y value? It's the negative 1. So I'm going to put in negative 1. The slope that I just found was 2 over negative 3, or negative 2/3. What's the x value in that ordered pair that's circled in yellow? A 2. And the only unknown now in the equation is b. So I can solve for it. So I have negative 1. 2/3 times 2 is 4/3, and it's negative. Plus my b. So, hey Chris, you'd asked about fractions and decimals earlier. This is one where we can't change it into a decimal because it's got a denominator of 3. So we're kind of stuck using fractions on this one, whether we, kind of like it or not. But we can, move the 4/3 to the other side with addition. So I've got negative 1 and I've got 4/3. How do I add fractions? Yeah, I need a common denominator. So this would be negative 3/3, right? Plus 4/3, which is equal to what? Yeah, 1/3. So my b value, my y-intercept, is actually crossing at 1/3. But I'm asked for the equation of the line, which means I need to finalize the equation of the line with the b value I just found. Slope was negative 2/3 times my x, and my b value is 1/3. Is that good? Okay, let's take a look at the next one. We're actually following through with the slopes that we found on the earlier problems, FYI. So we had found this one's slope from earlier to be 3 minus 3 over 7 minus negative 10, which gave me 0 over 17, or 0. That was my slope from earlier, okay? So using that information, if you recognize that it's a horizontal line, that's fantastic. Because what it means is that it's easy to write this down. So it's just y equals whatever the y value is. Bam, it's 3, I'm done. It's great. Sometimes we don't always realize or think about it from that perspective because we're sort of in the mindset of working with either the point slope form or the slope intercept form. So let me show you what happens if you're working with one of those forms instead and show you that you'll still get the same answer. So let's take a look at what happens with the point slope form because we didn't use that one in the last problem. So y minus y1 equals m times x minus x1. So the x1 and the y1 are where we're going to use one of my ordered pairs. And again, it doesn't matter which ordered pair I use. So you get to pick one. I usually just start with the first one, but it doesn't matter. So I'm going to use the first one. The first y value is 3, right? My slope is 0. My first x value was 7. On the left, I've got y minus 3, and what happens to the right because I'm multiplying by 0? It's just 0. And then if I solve this for y by moving my 3, I get y equal 3. So I will get to the same point, even if I don't happen to remember which particular line I'm working with. Okay? The last one we had found earlier to have an undefined slope. If you remember, we did 9 minus a negative 3 and 4 minus 4. So I had 12 over 0, and we all said that this was undefined, right? So undefined is trickier. It's trickier because I can't plug things in, because when I go over here to, say, for instance, I try to use this form of the line and there's an m, there's not a number to put in for m. There just isn't. Undefined doesn't mean 0. If it did, we'd just say 0. It truly means there's not one. So at this point, on a problem that has an undefined slope, we do need to remember that this is an x equals equation. And it's x equals whatever the x value is. In this case, it's 4. So my equation is x equals 4. Okay, we are not always given 2 points. We could actually be given a point and a slope, which is friendlier because now I don't have to find a slope, right? Absolutely. So we haven't done a point slope one that doesn't have a 0 in it. So let's try this with the point slope form. So y minus y1 equals m times x minus x1. Very friendly because I have all the pieces sort of just laid out before me. I don't have to find any of them. I have my ordered pair, don't even have to make a choice, it's just given to me, and I have my slope. So given that information, the y value that I'm given for y1 is 9. The slope value I'm given is negative 1/3, and the x value I'm given is 6. But as with the others that we work with, we want to solve it for y, right? Just like the previous problems. So we will distribute this through. So I have y minus 9 equals, I have negative 1/3 x. And then I have negative 1/3 times negative 6. What's that give me? First, does it give me a negative or positive? Let's start there. A positive. And then what's 1/3 times 6?
6/3 or 2.
6/3 or 2, right. So this one's a 2. And then what would be my last step to solving this for y? Yeah, adding my 9 to the other side. So I have y equals negative 1/3 x plus 11. All right. Let's take a look at one more piece of information about lines, and this actually talks about relationships between lines. Lines can have a couple of different things happen. They could sort of go side by side the whole way and never cross. Those are called parallel lines. They could intersect, or they could intersect at a 90-degree angle. Those are the three different options. So specifically, we're going to talk about parallel lines and perpendicular lines, right? Parallel lines means that they have the same slope because they never cross. So there have to be sort of rise and running, so to speak, right? At the same ratio. Otherwise, they'd eventually cross. So you should be thinking like railroad tracks, like Kickapoo and Harrison, right? The streets, they run parallel to it. I got the right ones, didn't I? Yeah, I didn't get the wrong one. Yeah, Kickapoo and Harrison should work. So they're parallel lines, all right? And then I have perpendicular lines. And so perpendicular lines, they cross, but they cross in a very specific way. And in particular, what we say is that their slopes are negative reciprocals. So if one of their slopes is m1, then we do the reciprocal, which would mean we flip it, right? And we make it negative. That's what negative reciprocals are. If it's a fraction or a whole number, whatever, we're going to flip it upside down. And then we're going to change it from positive to negative or negative to positive. So let's take a look at 8. On number 8, we are given an equation of a line. It's in standard form, which is not especially pretty. So the first thing we're going to actually do is change it into a y equals form. And we're given a point. So we're asked to find a line that is parallel to this one, and it's through this different point, negative 4, 2. All right, so the first thing I want to do is I want to take the equation I'm given, and I want to try and figure out what is the slope of that line. Because whatever its slope is, it's going to be the same as the slope I want to find for my line. So we're going to get it into that slope-intercept form of the line, because it's easy to see. So we'll start by moving the 3x. So that gives me negative 6y equals negative 3x plus 7. And then what would be my other step?
Divide the 6.
Yeah, we would divide by negative 6 on both sides. And in particular, we divide every term, and that's fine. I don't really care that I get a negative 7 over 6 as the y-intercept. It's sort of irrelevant, right? That's not part of what I care about. I care about the slope. So if we take a look at this particular slope right here, what happens to negative 3 divided by negative 6? Simplified version. Yeah, it's 1/2. So it's 1/2 x. The end of it, I'll write it out, just negative 7 over 6, but I don't really care. The m here is what I care about. It's 1/2. So now I have a slope of 1/2, and I have a point negative 4, 2. Let's use the slope-intercept form of the line so you can see that process again. So if you use slope-intercept form of a line, I know my slope, it's 1/2. I have a point xy, y is 2, x is 4, negative 4, and I can find b. So 2 on the left, what's 1/2 times negative 4?
2.
-2, right? Yeah. What's my last step to solving for b?
Add the 2.
Yeah, add the 2. So I have b on the right, and I have 2 plus 2 on the left for a 4. So now I have my b value, I have my slope value over here, and I can write out my equation in my line. Y equals 1/2 x plus 4. I have 2 more examples that I don't have time to do, but what I'm going to do is I'm going to go ahead and post a video. It'll be less than 5 minutes for you to just check in, watch those last 5 minutes so that we can finish up this section. We do have a quiz on Monday. It doesn't cover 1-4. It's just 1-1 through 1-3. So if you're doing the homework written problems, just do 1-1 through 1-3, okay? But WebAssign will be 1-3 and 1-4. Or not WebAssign, sorry. You guys are my math lab, different class. My math lab, 1-3 and 1-4. Have a great weekend.